Ever wondered how a simple change in a tiny value can reveal the hidden slope of a curve? Today, we unravel the magic behind derivatives using the first principles approach. As explained in our previous video, finding a derivative is essentially the process of determining the slope of a function. Consider a function f(x). A small change in x produces a corresponding change in y, denoted as dy because y depends on x. By rearranging the equation, we express y as f of x and define the slope dy by dx as f of x plus dx minus f of x whole divided by dx, where we eventually take the limit as dx approaches 0. This method, known as differentiation from first principles, was independently devised by Newton and Leibniz. It serves as the foundation for finding the derivative, or the limiting slope, of any function. Let's see an example by finding the derivative of x cubed using first principles. Start by expanding x plus dx cubed. X plus dx cubed equals x cubed plus 3x squared. X plus 3x dx squared plus dx cubed. Subtract x cubed to get 3x squared dx plus 3x dx squared plus dx cubed. Next, factor out dx, which cancels with the dx in the denominator, leaving 3x squared plus 3x dx plus dx squared. Finally, apply the limit as dx approaches 0. The terms with dx vanish, yielding f prime of x equals 3x squared. This result represents the derivative, or the limiting slope, of x cubed. Notice in the graph of x cubed that while the function takes on negative values for x less than 0, the slope remains positive, never dipping below 0. Unlocking the secrets of slopes not only deepens our understanding of calculus, but also reveals the elegant simplicity behind complex curves. Keep exploring and let the wonders of mathematics inspire you every day.